Hey everybody, I'm going to try and give you a video right now on the Chapter 2 calculator version, something that might help you out with some of the stuff. I know that there's been some lag going on with the video and my talking, so hopefully it'll go okay. I'm going to try and go a little slower with some of the stuff, but still give you some information. So here we go. There's some of the things you need to know to be successful with this. So Chapter 2 calculator version, and hopefully I won't screw up any of these things. So there's one problem definitely on there that says if you have zeros of like 4 and -3 and 2 plus I, can you find a polynomial in standard form? And then be able to write it out. So if you know that you have this, and I know that there was one on the non-calc, but this time you get to use the calc, so which means when you're done, you should be able to check your work on your calculator, right? Store these things in and do some substitution for it. So you know that you're going to have to do x minus 4 times x plus 3 times x minus 2 plus I, right? And then if 2 plus I is in there, then 2 minus I also has to be in there. So then you can do x minus 2 minus I. And you can multiply all those things together, which means I do this one first and then this one second, and then put those two things together. I'm not going to take all the time on the video right now to go through all that. I would also say that on this, maybe you understand that you could do this, that if you had 2 plus or minus I as your solutions, then this also must be true. X minus 2 squared equals -1. And these are the solutions to that thing, which means I could do this, x squared minus 4x plus 4 equals -1, or x squared minus 4x plus 5, when I move this -1 over here, that this polynomial is actually what you're going to get when you do these things together. So kind of knowing what the answers are will tell you what type of quadratic equation would deliver you those answers, right? Because again, we'd square root this, and square root that, and we get plus or minus I over there, and then we'd move the -2 to the other side and get 2 plus or minus I, which is what those solutions are. So just a shortcut for you, if that helps with that problem. Okay. There's going to be one like this again, 4 over x minus 6 plus 3 over x plus 2 equals, I don't know, like 18 over x squared minus 4x minus 12. So one of those types of equations. The different thing now is you could solve this algebraically, you could do it just by hand, but you also have your graphing calculator, so again, you can check. So both of these things are ones that your calculator will allow you to be able to maybe get someplace with a little bit faster. Okay. Hey, let's say I had one of these types of problems. Let's say I've got data here, 1980, 1985, 1990, 1995, in the year 2000, and maybe I have 14.2 here, and yeah, I have 18.4 here, and 20.7 here, and 25.2 here, and 30.9 here. And these represent millions of people, and I want to know what should I expect in the year 2023? How many people should I expect in that situation? Well, I'm hoping that you would look at this and you'd go, hey, it looks like this data probably looks pretty linear if you go through it like that. So I'm going to go here on my calculator, show you what you should do with this data. And I'll bump that like that so that I can see it without the without all that on there. So I'm going to go on stat edit here. Now, one of the things that we don't want to do necessarily is we don't want to use 1980 in the L1 column. So we're going to call 1980 year 0. So if 1980 is year 0, then 1985 is year 5, 1990 is year 10, 1995 is year 15, or 2000 is year 20, because that's how many years are after those time periods. Here, 14.2, enter 18.4, enter 20.7, enter 25.2, enter, and 30.9, enter. I have this data in here, and now I'm going to go to my stat plot. I'm going to turn that on. I'm going to look at a scatter plot, L1 and L2, right? I'm going to go to my window. I'm going to pick a window that makes sense. So this was 0 to, I can go about 25 years out for right now. I only need to go 20, but that's okay. And then here I'm going to go from 0 to, say, 35, knowing that these numbers are actually in millions. I'm going to go to my y equals, and I'm going to get rid of anything that I had from some other class. And I'm going to hit graph. And I can see that those lines kind of look like they're pretty linear, okay? It will be very pronounced if it was quadratic or cubic or exponential. So this one's definitely looking pretty linear based on that situation. So I'm going to go stat, calc, number 4, linear regression. I'm going to come down here to store regression equation. Remember, we do that with vars, y vars, function, y1, calculate. Okay, so you can see my R value is 0.99. I might get a higher R value for quadratic or cubic, but that doesn't really mean that the data is, just because the R value is higher. When you have a limited number of data points, then, you know, the higher the polynomial, the better it's going to match. Just because it has more twists and turns doesn't mean that the data is that. Now that I have this, I can go here. That's my equation. That's the best equation I can get. It was just copied in there when I did the store regression equation. And I'm going to go to right here. So second and table setup. And I said, well, what's it at 2023? Well, if I put in 2023 right there, that'd be bad. Don't do that, okay? Because this is years after 1980, where 1980 is year 0. So this actually should be 43 years later, right? So 1980 plus 43, 2023. I now go to my table setup, and you can see that there should be about 48.4 million people in this situation, if this was population or whatever change it was. I don't know, maybe it's fish. Maybe it's pebbles of sand. Whatever that number represents, it would be in the story problem. Okay, so hopefully that helps. That's a little run through on the calculator. You're going to have to do a couple of those ones, so make sure you're very comfortable with your calculator. If I said, when is it going to hit 100 million, then I would go here. I would put that up at 100. I would go to my window. I would put my y max at like 120, well above 100. I'd put my x max out at maybe 60 years. I don't know how long it's going to take, but that probably gives me enough time to get there. And then I'd go and see my graph, and that's, oop, looks like 60 years wasn't far enough based on this linear situation. Go to my window and go, okay, let's go at 100. And look at that. Oh, crud, window. And let's go out to 150. Definitely going to get there now. Second trace, number 5, enter, enter, enter. And you'll see that it would need to be 107 years after 1980. And you can easily do that. That would be 2087. Okay, So that's one of the runs on the calculator. Hopefully that was great for you guys. You need to be able to do 2-point summaries. 2-point summaries. And remember again, when we're talking about 2-point summaries, like if I know that I give you, so let's just do a quadratic. If I give you a vertex and I give you a point on the parabola, you 100% can go through and do your algebra. Or you could go, oh, Mr. Bells, I know enough about math. I know that this has to look like this. And if this point, and again, remember, I'm going to give you an actual coordinate. If this point is right here, it has to have a corresponding point that is directly the same y height, but however far that is away from the vertex, it has to be that far in that direction to get to the other point. And now I have 3 points, and then I could use my calculator again, stat calc, and do number 5, a quadratic regression, and I can get an equation from that. So if I had a cubic, I could do the same thing. I just have to use my brain a little bit more on how to be able to get 4 points, and that's up to you guys to be able to use those types of things. Okay. I've got some of this stuff, like I said. Here we go. F of x equals 4x plus 2 over x squared minus 6x plus 7. And I want to know when f of x is negative. Okay? So when is that negative? I could take 10 minutes and try and scratch this sucker out and find out where the zeros are and make it look pretty and perfect. Or I could go, wait, Mr. Bell said this is my calculator test. And if it's my calculator test, then he probably wants me to use the technology in my brain to be able to get this. So I go ahead and grab the calculator and I put in 4x plus 2 divided by x squared minus 6x plus 7. I go to graph that, and I'm feeling really good about myself. And then I have that pause, that wait. And I look over in the far left corner of the room, right by the DIMS poster, and right below the DIMS poster, there's a poster, a little thing that says something about, what is that, parent, parentheses. Yes, parentheses. And I go, I'm not going to lose points on this test right now because of the fact that I just forgot to put parentheses on an obvious problem where I need it. So I go back here and I go, hey, I know that I got to insert parentheses there. I got to insert parentheses there. I got to insert parentheses there. And I got to close them off over here. And then I can hit zoom 6. And it looks like, to me, that it's negative, right? It's negative between these two things here, whatever these asymptotes are. And I would know what the asymptotes are because I could just find the zeros of this thing, and I could do the zeros of that through completing the square, quadratic formula, or I could just graph it, or I could watch in just a second. I'll do some Tracy stuff. And it looks like it comes through and touches someplace in there. So I could go y equals 0, like that, yeah, and then hit graph. And then I just find the intersection right here. So second trace, number 5, enter, enter, enter. And I know that it's, again, negative, which just means it's below the x-axis, from negative infinity to negative 0.5. And then as I go right here, as I hit trace, and I move, trace, and I move up this thing, and I go down, you can see that it looks like that maybe that's at around 2-ish, but I really can't tell for sure. So what I'm going to do is I'm going to look at just my denominator. So So I'm going to get rid of that because I need to know those two places where it hits 0, because it's between those two things. So I'm just going to hit delete on all of this and just look at my denominator. When I hit graph, I can see that it touches at those two places, and those two places will become the vertical asymptotes for my other graph. So then it's going to be below or negative wherever the denominator is, below 0, 2. So second trace, number 5, enter, 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 from 1.585. Second trace, number 5, enter, 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 to 4.414. Okay? So again, hopefully that is beneficial to you. It might not be this, it might be some other equation, but it's just about, can you use your technology to understand it and then pull the stuff from the graph. Okay, so there's also going to definitely be a problem like this, and I don't have it written out right now, but let's say it's x to the 5th plus 4x to the 4th minus 3x cubed minus 2x squared plus 6x plus 2. Something big like that. And I'm going to ask you to find all the zeros. Okay? Now, just to be clear, I can't just make this stuff up. And I did for it to have it. But you'll be able to graph it. And on the graph, you'll see that it does something like this. Potentially. And you'll be able to go, hey, I know there's a 0 there, there, and there. I'm going to use synthetic division with that number, and with that number, and then that'll reduce down to a quadratic of some form. Okay? Just to be clear, everybody, right? You listening? This is not this one. This is not one that works. I just made up those numbers. But if I do synthetic division correctly, for whatever one's on the test, it will come down to a quadratic. And once we have that quadratic, then we can CTS or quad formula to be able to get the remaining two zeros. Now, I'll take you through one of these right now just in case it's messy and scary for you. Let's say that I got down to this x squared plus 7x plus 16. Well, x squared plus 7x plus 16, if I do this right now, if I go to my y equals, if it hits the x-axis, then hey, I didn't have those imaginary ones. So I got it, x squared plus 7x plus 16, and I hit graph. And I go, oh crud, it doesn't. This has imaginary solutions, so I'm trying to find those. I'm trying to find where it equals 0. So what I'm going to do is I'm going to go x squared plus 7x equals negative 16. I'm going to take half of 7, which is 7 halves, and square it, which is 49 fourths. And if I add 49 fourths to this side, I'm going to add 49 fourths to this side. Then I get x plus 7 halves squared equals, well, this is negative 64 fourths, and that's 49 fourths. So that makes a total of negative 15 fourths. And then I get x equals, because I have to square root both sides, x equals negative 7 halves when I move this to the other side of the equation, plus or minus, and this is going to be weird for you, I root 15, pull the negative out, gives me the I, and I'm going to pull the 4 out of the radicals because the square root of 4 is 2, and you can see now they're both denominators by 2, so my solutions are x equals negative 7 plus I root 15 over 2 and negative 7 minus I root 15 over 2. It's okay? Those are my other possibilities. Again, that's a big process for the whole thing, but I believe in you. You can do that. Okay. Obvious one, this was on the last test, on the first test. It keeps showing up again. So I got this box right here, yeah. This open top folded box volume problem thingy, except now it's even more important to it because we're dealing with cubic functions, not just graphing our stuff. So let's say that this was originally 40 by 60. That's a big box, 40 by 60, and we're folding up these edges, which are all going to be the same. So then my volume of my box is 40 minus 2x times 60 minus 2x times x. Those are my 3 dimensions. Move that up a little bit. And don't start multiplying this together. Don't start doing that. Man, look at. I got this thing. This thing's awesome. I'm just going to take that. I'm going to put that right in my calculator. I'm going to go to my y equals. I'm going to go clear. Parentheses 40 minus 2x, close parentheses, parentheses, 60 minus 2x, parentheses, x. Length times width times height, or width times length times height. It'll say it in the problems which ones are which. I go to my window, and I'm like, my fold, I can do 0 to, I'm going to do 60 right now. Sorry, 0 to 60 right now. Technically, I know my fold can't be more than 20 because, the shorter side's 40, but I just wanted you to see the whole thing. My y-min, this is a volume. Again, 40 by 60, that's a pretty big thing. My volume might be pretty big in terms of its cubic inches. So I'm going to go from like -500 to 4,000. I might have to go bigger than that, but that's what I'm going to start with right now. And I hit graph. And you can see, oopsie, I still have those dots from before. Turn my stat plots off. It's like that, second y equals to turn those off. And I realized that I actually have a volume bigger than 4,000 cubic inches. I'm going to go to 8,000 cubic inches and hit graph again. Holy crap, it's bigger than that. Window, 10,000 cubic inches. Now I can definitely see. Okay? And all of these things are volumes based on however much I fold this thing up. So if I fold it up an inch, so I'm going to go to the table setup and show it to you here. If I fold it up 1 inch, I can get a very, very, very pizza-esque like box with 2,204 cubic inches in it. If I fold it up 2 inches, it goes to 4,000 cubic inches. 3 inches, 5,508. 4 inches, fold 6,000. And you can see that someplace right in here, it reached a peak because it's at 8,372. Now it's at 8,448. Now it's going back down again. So between 7 and 9 inches, it had to hit its peak. And you can see that obviously right there. So second trace, number 4 maximum. I'm going to go 1 inches, enter, and I'm going to go 12 inches, enter. I'm just picking 2 random numbers that I know are on the left and the right side of this. I'm going to say guess. Nope, I don't really want to guess. And you can see that it says that if I fold it up 7.84 inches, 7.847 inches, 7.85, I don't care, that will maximize my volume of 8,450 cubic inches. Let's say I wanted the box to be 6,000 cubic inches. So then I go to here, y equals, and I say, oh, well, let's make it 6,000 cubic inches, and I hit graph. And you can see that it can happen once there, and these don't matter over here, right? Because this is a byproduct of 2 negative numbers, and I can't have negative distances. It's just a mathematical result to a true equation, not a physical real result. Second trace, number 5. Move my cursor over here, enter, enter, enter. And you can see that if I folded my box up 13.2 inches per side, I could get 6,000 cubic inches of space. Or second trace, number 5, move it over here, enter, enter, enter. I could get 3.39 inch fold to give me 6,000 cubic inches. Now, on each one of these things, we talked about also that these sections right here are ones that we're going to throw out when we fold this box up. So this would be considered, the stuff in the red would be considered the waste. And if I wanted to find out percentage waste, that would be 4 times the area of one of those squares divided by 40 by 60 in parentheses, right? Or the area of the whole thing. So area of the waste divided by area of the entire thing. Remember, volume, when we fold it up, has nothing to do with percentage waste. Percentage waste is out of the material that we have, what am I throwing away? Now, yes, it's also those flaps too, for anybody who was zoning out on me. It's all 4 of those things. That's why it's 4 times right there. Okay, so hopefully that's helping. There's going to be one where we take an object and we shoot it up into the air and it comes back down looking like this. Where I said, hey, use your technology. Find me that maximum value. Find me where it hits the ground. Find me where it starts at. Find out how far it's gone between these two things, which just is the difference between y values. All kinds of different questions I could ask, but it's all about using your graph, right? Using the graph to be able to get the information. What else do I have? Looks like I do have a bonus question on there, so good luck with that one. And I've got some other questions on maybe some sort of funky model, something like this, or some polynomial that I give you. And then I ask you questions about using that polynomial. So again, it's about this. Can you put it into your calculator? Can you answer questions about that? Can you find where the highest points, lowest points, fastest points, whatever it is, stuff that you can do manipulating your tech. Okay, so hopefully that helped with it. Hopefully the delay on the camera isn't too bad, because that really gets annoying with it. Don't know if I have to update some software because it's been kind of an issue with it. So thanks for listening. Be positive with it. Make sure you have charged batteries in your calculator for tomorrow. It is not open notes, so know your stuff. And hey, let's do this. For the first 5 people that send me the message, green caterpillar, then I'm going to give you some extra credit points and say thanks for watching the video. So 5 extra credit points on the test. Green caterpillar. Good deal? Now, I want to make sure everybody's listening and followed it all the way to the end. Have a great day. Be positive in your knowledge and that you're prepared for it, and you're going to do really, really well tomorrow. That was helpful.